In this lesson, we are going to learn about looking at a solution quantitatively. And that is how we quantify a substance in a solution. So what is a solution? A solution is basically a homogeneous mixture of a solvent and a solute. But wait a minute, what is a solvent and a solute? A solute is a substance that is being dissolved by a solvent. One common example is table salt. You take table salt and you put in water. What happened to the table salt? Over time, the table salt will be dissolved by the water. So then we have the term solvent. Solvent is a substance that is doing the dissolving, in this case, water. So water is dissolving the table salt to the point that you will no longer see the table salt and it has become a homogeneous mixture. So how do we quantify the amount of table salt in this solution? We use the unit molarity. And molarity, therefore, is a unit of concentration that is defined by this equation. Molarity is equal to moles of solute divided by liter of solution. But if we kind of think about this, a solution to some extent is basically a combination of solvent plus solute. However, the volume of the solute is so small, sometimes we ignore it, okay? But notice that the solute is always in the solution. In this case, to make a 4.00 molarity of sodium nitrate solution, how many moles of solute will be needed if 12.0 liters of solution are required? So again, we just have to plug in what we know from this equation. We know our molarity, so that goes right there. And we know our solution number, so that goes right there. So instead of using moles of solute, we can say, hey, that letter X represents the mole solute, and we say that's X over 12.00, and the molarity is 4.00. Notice I did not write down the unit anymore because I don't want to use this as a process of canceling unit, but I want you to see this as a process of solving for a variable using your basic math skill. So how do I solve for X? Of course, I multiply both sides by 12.0, that cancel out, and 12.0, and that gives us X equals to 48.0. Now what does that mean? That 48.0 is actually 48.0 moles of solute based on our equation. So again, using this basic math skill, you can ignore the unit and we don't have to worry about a bunch of numbers and letters at the same time. But what about solute? One important information that we need to think about is the term solute itself. Do we know the identity of this solute? That is, do we know the chemical formula that's involved? In this case, we are talking about a solution that consists of sodium nitrate that's being dissolved in a solvent that is not given to us. So we can think of solute, cancel that out, and we can say, hey, this is 48.0 moles of NaNO3. And why do we care so much about the chemical formula of the solute? Because now you have moles of a chemical formula. What can we do? You can now apply to the stoichiometry flowchart. Notice how we have mole. With mole, you can convert to any of the chemical formula to any of the unit on the flowchart if a specific relationship is given, especially the mole-to-mole ratio. Go to streamlayer.com to download ready-to-use online practice with immediate feedback. You don't have to make copies. All of your student work is auto-graded. This will save you a lot of paper and hours of grading. The links are in the description below. Thank you.